Ladies and gentlemen, Ben Edgington.
Thank you. Thanks, Cam. So this is my topic tonight, Ethereum 2. I mean, I guess quite a lot of people are just getting used to Ethereum 1. What is this Ethereum 2 thing? I should warn you, this talk normally takes about 90 minutes, but I don't want to get between you lot and the pub. So I've done some drastic slashing. So forgive me if some of it goes by a bit quickly, but I'll be around a bit later if you want to talk about any of these things in a bit more depth. Can I use this thing? Hey, it works. Just quick introduction of who I am, where I fit in, and what are my credentials to talk about this stuff. I've done this very nice simplified diagram. We've got this Ethereum community. Now, the Ethereum community doesn't look anything like this. It's messy, it's chaotic, it's complicated. But for the purposes of this evening, it's a nice ellipse. And I got involved in Ethereum stuff about 3 years ago. But now, where do I live? Well, we've got this another nice ellipse, and of course reality is nothing like that, which is ConsenSys, the company. Now 1,000 people worldwide, all working in the Ethereum space. And within ConsenSys, there's the group I belong to, PegaSys, which is protocol engineering and systems. We're focused on public chain Ethereum protocols and also enterprise Ethereum protocols. And within that, I'm in the R&D team. There are about 12 of us now, growing rapidly. And 7 of us in particular are working on Ethereum 2, which is next generation Ethereum protocols. So this is the point. Ethereum's mainnet. The Ethereum you know today is, some would say, overdue an upgrade. Why is this? What's the problem with today's mainnet? Well, first problem is it's, we could say, a victim of its own success. So for the first couple of years, this graph shows the percentage of block utilization. So what percentage of capacity is the Ethereum network running at all the way from its inception 3 years ago right up to the present day, or a couple of weeks ago. And for the first couple of years, unremarkable, running about 5 or 10% of capacity, no big deal. Couple of little spikes, the famous infamous DAO hack in June 2016 keeps coming up. Then we've got the network spam attacks just before DEFCON 2, this sort of blip there. And then sort of towards the second half of last year, ICO fever, then CryptoKitties fever, and then since then, the network's been running at 95% capacity or so, which is bad news for a network. The upshot of that, at the time, 64,000 pending transactions. That's well over an hour's worth. And today it was over 70,000 when I checked today. This means increased transaction cost. It means that you don't know when your transaction is going to get into a block. It could be any time in the next hour. It's not a great user experience. What's the other problem? The other problem is a bit more subtle, perhaps, but what happened to the innovation on Ethereum? I mean, when I joined the community, it was understood Ethereum was the exciting one with the roadmap. It's where the innovation was happening. We're going to move fast. We're not going to break anything. So here even from the earliest days, scalability was on the table. It was called chain fibers in those days. You got Gav Wood, April 2015, but actually if you read the article, he came up with this idea in early 2014. Proof of stake was also talked about for the Ethereum network. That's the main reason I was excited about it at the time. Again, nearly 5 years ago now. And this is why I joined the community, because unlike other blockchain communities at the time, things were happening. But it's 3 years later, it's 4 or 5 years later. We don't even have bit shifting in the EVM yet. I mean, it's taken 3 years, and that's still not there. It's going to come in the Constantinople fork. It turns out that doing innovation on a network that's worth billions of dollars is just really hard. People are just ultra cautious. Nobody wants to do anything which is potentially disruptive, and innovation has slowed almost to a crawl. And that was kind of understood. I mean, this is from Vitalik. This is a bit of archaeology going back 4.5 years. And the point is, you don't need to read all the text, but we fully expect we'll end up releasing Ethereum 2 at some point in 2020. Well, nearly 2016. I think we're a bit delayed from that, but the point is that an upgrade to Ethereum was always part of the plan. And the take-home message tonight, if you remember nothing else, the take-home message is, it's happening. Okay, what's happening? So, I'll tell you about Ethereum 2. And basically, this is a brand new blockchain. So, I'll explain what I mean by that. The two big themes here are proof of stake. So this is what you may have come to know as Casper. It's a kind of son of Slasher, that protocol that Vitalik wrote about 5 years ago. And sharding, which is scalability. And this is the child of chain fibers, Gav Wood's protocol. And the plan until quite recently was that each of these would be separately put onto the current mainnet as contracts. So you would have a contract that managed the proof of stake. You would stake your Ether into that contract. It would manage the validators for proof of stake, and all of the rules and everything would be on the current mainnet. And similarly for sharding, this scalability protocol, you would have a contract, and that contract would manage your stake and the validators and all of that. But around June time this year, there was a big sort of upheaval to this plan, and on further examination it was decided that this was not really going to be feasible. The current mainnet is too busy. Adding protocols, fundamental protocols on top of it was not going to be reliable because the transaction volumes are not available, and there are various sort of protocol issues like minor front running and sort of things which just made it difficult to implement on the current mainnet. So around June time, there was a new plan, and this plan recognized that these two big innovations have a lot in common, and there's a lot to be gained by unifying them and doing them together, and in particular taking them both off the current mainnet and then putting them on a separate side chain to the current mainnet, and I'll show you a picture. And that would solve a lot of problems and make it a lot more feasible and practical and really unblock the route to delivering these things. Diagram is the next one, but I mean, just in terms of the overall design goals, what are the design goals for this new blockchain, which we're calling Ethereum 2? Well, there are a couple of things it is got to have, and those are the two things I just mentioned, proof of stake and scalability, because they've always been part of the Ethereum promise, the Ethereum contract, as it were. But in delivering these, there are some qualities that we have to maintain. So decentralization, so as we design these protocols, decentralization is key. It has to be possible for anyone who wants to participate in securing the network to participate. As low as possible barrier to entry is a design goal. You shouldn't need to have a supercomputer or a server farm or an ASIC to join the party. Another design criterion is availability. Now this is a decentralized systems thing. The thing is, the idea is that no matter what happens to your network, it keeps running. Other blockchain protocols don't favor availability, they favor consistency. So if something threatens the consistency of the data on the system, then the system stops. So Dfinity protocol is like that. If the network becomes split, the two halves will stop and nothing will happen. And that maintains the integrity of the data. However, the vision for Ethereum is as critical national infrastructure. Banks, hospitals, who knows, will be power companies, should be building their infrastructure on it. It can't stop, it has to keep running. So this is the kind of the World War III scenario, or the Brexit scenario when we're cut off from the rest of the world. Will it keep running? Security, of course, is paramount. Ledger integrity, under normal circumstances, it should remain, I won't use the immutable word, oops, just did. Usable, easy to build on. Continuity, so this is interesting. I've characterized this as a brand new blockchain, but of course it's got a kind of inherent value from the current Ethereum. We don't want our current Ether to go to zero or to become useless. Somehow that value's got to continue into the new blockchain. So there is a continuity between current Ethereum 1 and Ethereum 2. Now, those are the kind of the mandatory things, but another advantage of moving all of this innovation off the current mainnet is it kind of unblocks everybody's pet project. So, for example, EWASM has been talked about for a long time as part of the Ethereum protocol. Very difficult to implement on current mainnet for all the reasons I've mentioned. But because we're doing something new, we can bring in these new things like EWASM as the execution engine. Quantum resistance is a big topic. Who knows how long until quantum computers are able to crack the current cryptography. It may be 30 years, but it may not. And other things which I won't go into now for sake of time, and some things that could be in it, storage rent, different kinds of proof-of-stake consensus. So what does it look like, this thing? So this is where we are today. This is the proof-of-work main chain, which I call the kind of anchor chain, and this will chug along, producing blocks on average every 15 seconds for the foreseeable future. So nothing changes in that respect. Alongside this, we're going to be adding this beacon chain, which I call the coordination layer. Now, it doesn't do any processing of user transactions. You can't submit a transaction to the beacon chain, but it maintains the proof-of-stake and the sharded system, and I'll explain the sharded system in a moment. So it does all of the maintenance of people's stakes, enforcing the rules of that system. It generates random numbers, which is an interesting topic all in itself, and just maintains itself. Next is what we call the data layer. So this is the blockchain. This is a sharded blockchain. This is 1,000 blockchains executing in parallel alongside each other. Now, in this architecture, each of these shards is not doing any processing. It's not doing any state calculation. All it is maintaining its own ordered log of transactions. And that's what blockchains do at their most fundamental. They take all the transactions that come in and just log them in order. And then you can recreate the state by replaying the transactions. So, and at that stage, that's all that these shards are doing, taking their own transactions and creating an ordered log. And then the final stage is the execution layer, where you put an engine on top which can actually interpret the transactions and is able to calculate your state, your balance, how many CryptoKitties you have, and so on and so forth. What are we changing? Right, you don't need to look at this. I just wanted to put this up as a just a placeholder to say we're changing everything. So there's a lot of lessons learned, a lot of developments, a lot of new technology, even since Ethereum was first designed. And I'll drill down into each of these in a little more detail. But what's the scope of work? It touches everything that makes a blockchain system. We're touching the ConsenSys protocol, the concurrency of the blockchain, the crypto-economic model. We're changing the cryptography, the state transition, which is what I just talked about, the way it calculates your balances and so forth. The data structures used under the hood, the networking layer, the way that transactions, smart contracts talk to each other, how they talk to each other across shards, and so forth. So, it really is a reworking of the current Ethereum. So just to go through these quickly, and this is really just to raise the topics. If any of these are particularly interesting to you, come and grab me and we can talk about them in a bit more detail. But we're changing the ConsenSys protocol. Today is proof of work. We burn huge amounts of electricity just doing these useless hash calculations in order for miners to get the right to mint a block. This is horrible. This is going to be replaced by proof of stake. So this whole system, the beacon chain, and each of the shards will run a proof of stake protocol. So that means that people will stake Ether, 32 Ether, to become a validator in the system. Now, proof of stake isn't on its own a ConsenSys protocol. It's just kind of part of a ConsenSys protocol. There'll be committee-based validation. That's a bit different. Today, every node validates everything. In the new system, committees of nodes will validate certain parts of the system. and those need to be organized, and that's why we need random numbers, so they can be randomly selected, randomly shuffled, and this is how the security of the system is maintained. And there are some of the benefits to changing the consensus model, you know, the obvious environmental benefit. Finality, on the current Ethereum, on current Bitcoin, nothing is final. It can all be replaced if there's a 51% attack or something like that. It can be wound back as far as an attacker likes. In the proof of stake system, you can declare finality at certain points where all participants agree we will never go back beyond that block. That state is as near as immutable as you can possibly get. Decentralization I mentioned already. Regular block times is a minor thing, but it's a usability thing. Currently, next block might be minted in a second's time, or it might be a minute. In the new system, it will be, well, there's some debate about the interval, but probably 8 seconds, and it will be regular clockwork block production. Concurrency. So the world computer, the Ethereum, the world computer. The world computer is single-threaded, which is alarming. You know, even my laptop's got you know, multi-cores. But currently, every node runs every transaction, and they run serially. And this is the bottleneck. This is why Ethereum can't scale more than it currently does, because every laptop, you know, whatever the participants are, have to verify every transaction serially. So what do we do in sharding? We split that workload up. So we've got these 1,000 shards. Each of them takes 1,000th of the state and a 1,000th of the transactions coming in on average. And so you can run this like a massively parallel computer, running all in parallel. And your throughput, your capacity of your system increases by at least 1,000 times. There are other things like this, regular block time and things, which mean you can increase the transaction capacity as well. So this is immense scaling of the blockchain capacity. What about crypto economics? Now this is a tricky topic. Current crypto economic model in Ethereum is very simple. It basically revolves around miner rewards, and it's only reward based, and you've got some subtleties around gas costs, but nothing too complicated. In the proof of stake system, it introduces a whole new slew of crypto economic levers. So you've got staking, so people actually have to put down ether to become validators. It introduces not only carrot, rewards for staking or rewards for mining, but also stick. You can be punished if you behave badly. Stake can be taken away from you. And all of these need to be analyzed very carefully because they're very easy to get wrong and to have perverse incentives in the system that actually end up doing things, you know, incentivizing people to do things which you hadn't imagined. You know, things like selfish mining are an example of that. Cryptography. It's one of the kind of ironies of cryptocurrencies that until now they haven't really done a lot of cryptography. I mean, it's basically hashing and signing, which are pretty basic cryptography. Honorable exception may be Zcash. In Ethereum 2, we're going to go large in cryptography. So randomness is a huge topic. It's needed in protocol to manage all these validators and sets of validators. But also high quality randomness. We're looking at putting that in place and allowing applications like lotteries and so forth and other perhaps more worthy applications to access randomness, because that's a huge missing piece of current blockchain technology, which is actually very useful. Looking at changing the hash functions, so currently it's the Keccak hash. That has some inefficiencies, so probably Blake2 and a new hash function called Mimic will be used. Signing of transactions, so the current, we're looking at using BLS signatures because you can do interesting things with BLS signatures. You can aggregate many signatures into a single signature. This is very useful when you've got a committee of 1,000 nodes that have to sign off on a transaction. You don't want to be having to check 1,000 signatures all the time. If you can combine those into one signature, then that makes the whole thing much more efficient. So you can do that with these BLS aggregate signatures. Looking at changing the elliptic curve, I mean, jury's still out on exactly what we're going to use, but it won't be the SecP curve that's currently used. In due course, when the protocols are a bit more battle-hardened and understood, ZK Starks is a zero-knowledge proof protocol, which could be extremely useful in the blockchain system, in the Ethereum system, to prove certain things. So light clients can accept a ZK Stark as proof that the data that they've received has been calculated correctly, for example. And then there are other protocol level stuff like fault proofs, data availability proofs, which I won't go into. Changing a state transition. Today it's very simple. There's the Ethereum virtual machine. It runs synchronously with the transactions. Every block, the miner executes the transactions in order on the EVM, then calculates the new state of everybody's accounts and contracts and so forth, and then the state root is calculated and gets put into the block. So it's all completely synchronous and done, in lockstep at every block. One of the interesting possibilities is delayed state execution. You may know about functional programming, Haskell, for example. You can store up transactions and you store up the list of calculations that need to be executed, and you only actually execute them when somebody wants the result. So I might go for months without checking my balance in my account, and then I want to know it one day, so I log on to an executor node, I check my balance, and maybe for a small trivial fee, it will root out the transactions that have affected my balance and calculate it on demand and provide the result. And this could be a huge efficiency gain in the system, because a lot of the calculation is probably quite wasted today. That EWASM is another big topic there. Data structures. Yeah, I mean, just to say we're changing, lots of stuff under the hood. So Patricia trees are part of the protocol of current Ethereum. There are alternatives which may be very useful. Even famous RLP serialization is changing. Peer-to-peer networking, dev P2P is a bit specialist. Looking at moving to something called libP2P, which can handle this sharded system. So if you've got 1,000 blockchains running in parallel, they don't need to see each other's transactions all the time. That would be a problem. You want to be able to direct your transaction so that it's shared only amongst the participants in one shard. So you need a protocol that allows messages to be multiplexed so that they're not being broadcast to all participants, but only the subset that really need to see them. libP2P gives us that kind of capability. And then there's a whole sort of cross-shard transaction piece. So currently, if you execute a contract, calls to other contracts are synchronous. They get executed, the first contract waits for the result, the thread just carries on in the other contract, it comes back, and you've got the result, it's fully synchronous. Cross-shard transactions are more natural in an asynchronous model, where you make the call, then you go and do something else, and then you maybe get a call back, and deal with the result. That's a kind of more natural programming paradigm for this sort of parallel shard model. But it's, is it reasonable to have one calling convention for in-shard transactions and a different calling convention when you're doing cross-shard? Do we really need developers to be aware of where contracts are in the sharded system and so on? So there's a lot of work to be done in terms of the programming model for this stuff, and is there a sort of unified model or what's best on that front? Okay, so that's a really whistle-stop tour of what Ethereum 2 looks like. The big question is when? Let me first tell you about how, and the kind of the people who are developing it and so forth. Research and so forth largely led by the Ethereum Foundation. Vitalik said a couple of weeks ago that there are no significant unsolved theoretical problems left for Ethereum 2, which is good news. There are quite a lot of interesting problems to solve, but I think the big rocks are in place. There's a spec for this beacon chain, which is being worked on at the moment, so we can build this thing. Various teams are implementing it, which I'll show you in a moment. There are workshops every 3 months or so. Next one's in 2 weeks at DevCon. We do fortnightly calls. There's a Gitter channel you can look at. What I'll do is I'll put these slides, I'll push them out on Twitter. This is my Twitter handle, and you can follow the links and you can see this stuff if you want to look into it for yourself. Teams, there are 8 teams globally that I'm aware of who are actually working on beacon chain implementation, so putting this code into action. The idea is early next year to have a test net where we can get this beacon chain bit up and running. It turns out that this architecture diagram is also a project plan, so it's the stages in which this stuff will be delivered. Now, this is totally straw man timescale based on some speculation from one of the Ethereum Foundation researchers. It could be shorter, it could be longer. I'm hoping for shorter, but the idea is that within the next year, probably testnet early next year, we deliver a beacon chain that is interoperable between the client teams. A year later, we do this shard chains that process these logs of data and prove that we can do the communications and handle all of the logging and everything necessary. And then about a year later, we put the execution engine on and make it, fully usable as a programmable blockchain. Just quickly, that seems like a long time, but there are alternatives. One of the good things about this kind of crunch in Ethereum, which has slowed things down a bit, is that people are starting to look at where stuff should be done. Not everything should be done at the layer 1 protocol. Not everything needs to go on the blockchain. It's much better if people think very carefully about where they put their data and what actually needs to go on the blockchain. And 2 years ago, when it was really cheap and really easy to put everything on the blockchain, everyone just wrote very lazy code and just put everything on the chain. But now people are focused on actually working out really what's the minimum we need to do on the blockchain, and that's the right question. So things like Plasma, state channels, TrueBit, and so forth are working in this space, and there's been a huge explosion in activity in this stuff lately, which is great. Final remark from Vitalik. Ethereum 1 is a couple of people's scrappy attempt to build the world computer. Ethereum 2 will actually be the world computer. Okay. Go.
They say that randomness, in order to decide who signs the next block, randomness is a data that has to come from an external world, which is what Bitcoin source is the nonce data. And otherwise, you cannot prevent civil attacks, third-tier attacks, and phishing attacks. Is that
right?
Addressable somehow?
Yep. So randomness, basically it has to come from outside. So the basic model is within the protocol to use a Randall construction. Now, so that means the participants, so basically the validators, commit their own random data, and this is kind of mashed up into a random number at each block. There are problems with that. It's biasable. The last person to contribute can decide whether to contribute or not based on whether they like the outcome or not. The protocol has been hardened so that it's resistant to small amounts of bias in the randomness. So that Randall construction, we believe, is good enough for the in-protocol randomness. If you want a high-quality, unbiasable randomness, you need to do something more sophisticated. This is where this verifiable delay function technology comes in, which we can talk about or you can look up. I mean, it's a long story, that one.
What's on the roadmap for Whisper and Swarm?
Yeah, great question, which I don't know the answer to. So I'll tell you after DEF CON. Whisper and Swarm, yeah, sorry. Sorry, I think...
I have 3 little questions. The first one, do you plan to have a migration from Ethereum 1 to Ethereum 2?
Yeah, so migration from Ethereum 1 to Ethereum 2. So there are kind of 2 levels of that. There's kind of Ether migration. So there will be effectively a one-way transfer into the new chain. So stakers will stake on the old chain. That will be locked, and then when they want to release their stake, it will come out in the sharded chain, and then later people will be able to transfer across into the new chain. What happens to Ethereum 1 in the long term, the current mainnet? One possibility is that the whole state of current Ethereum, however big it is, gigabyte or something now, is transferred to a contract in the sharded chain, and you run the EVM as a smart contract. You can do that on eWASM, it's available today. And so effectively, the whole of current mainnet becomes one contract on the new chain, and we preserve, you know, all the stuff that's out there today remains preserved. And then you can shut down the proof of work chain. And so it's fully proof of stake then.
Thanks a lot. The second question is quicker. Just to be sure, the proof of stake is fully decentralized, and if you have 51% of people who stakes, they can gain the 49% of the other who stake against, right?
Right, so yeah, 51% attack is a problem for proof of stake, proof of work. Proof of stake system should be safe against up to a third of Byzantine or bad actors. So it's probably not as strong in that sense as proof of work. So yeah, the basic modeling has been done around up to a third of participants being, or 2/3 being honest. So yes, and in terms of decentralization, you know, there's lots of argument about this. I would argue that the inherent centralizing effects of proof of work, like, you know, cost of power, cost of cooling, and you know, economies of scale, make proof of work inherently very centralizing. Proof of stake maybe has different factors, but I don't think it will be as strongly centralizing as proof of work.
I have a last question. Vitalik said recently that storage on chain should be paid.
This is the storage rent. Yeah, I mean, it's on one of the slides. I went past it very quickly. It's being talked about for the, you know, maybe Ethereum 3. I mean, in that term, no blockchain at the moment does storage rent. The point is, you can put data on, you pay once at the beginning to kind of 20,000 gas or whatever, and it's there forever, which is kind of odd, you know, and nodes around the world have to maintain this forever. So the idea is that you periodically incrementally pay for what you store on the blockchain, and there are ways to make that work. But yeah, this is speculative. Yeah, yeah. Have we got time for one or two more, Cam? Yep.
Sure. The Bitcoin,
Yeah.
Bitcoin developers couldn't agree on changing one tiny aspect of their protocol. Why is it going to be so much easier for you to change absolutely everything?
It's a great question, and you know, if you want to find out what the Ethereum community is like, and you can do your own compare and contrast. I'm not going to say anything from up here. You know, you can sit in on the calls. They're on YouTube, so the fortnightly Ethereum 2 calls are there. You can follow the Gitter, you can follow the ETH research site, and you make your own mind up about why the Ethereum community and the Bitcoin community differ. But yeah, I'm confident that we are pulling together. That there aren't going to be any nasty forks or disputes.
Hi, thank you for your presentation. So in the vision, you had the layer 1, which was the proof of work or main chain or anchor chain. And so is it correct that what you're saying is let's stop using the existing chain and launch a new chain, which is going to be this main chain? Or is it not possible just for the current mainnet to become this new POW, anchor layer, and then build on top of that? And I don't understand all the technical requirements around that, if it's possible or interesting.
Yeah.
But the other thing is with the proof of stake. So from an economic perspective, I think there's very strong arguments that actually it leads to more centralization than things like social dominance and compared to proof of work. And I mean, we could spend hours and hours taking this. But yeah, that's why also I'm following to see some of the new chains that are being launched with proof of stake natively, to see how they develop and how they evolve and what happens. So I think we'll be having this debate for the next 5 years.
I'd like to give it a try. I mean, you know, so is proof of stake going to be centralizing? We'll find out in a few years' time. And I don't think it can be worse than proof of work, but who knows? It's got to be done. I don't think proof of work is sustainable, you know, at all.
Awesome, thank you so much, Ben. I think we have one more question from this side of the room. So there's a few people. Who wants to ask a question this side of the room? I saw your hand up. Not today. All right, how are we doing? Okay, here you go.
Hi. I was just wondering, is there any thought to putting in some further incentives to encourage the level of decentralization amongst the validation nodes?
It's very, so encouraging decentralization is a difficult problem because a centralized person, you know, a person with a lot to stake can behave like a decentralized person, you know. So if I've got a lot of ether, I can put down a lot of 32 ETH stakes, and nobody knows it's just me. So it's very difficult unless you combine it with some identity anti-Sybil mechanism, which is, you know, and all identity assurance mechanisms are somewhat centralized. I mean, it becomes a problem. So the only way is really to give no advantage to people who seem to have bigger stakes in the protocol, but it's hard to do.
Cool, fantastic. Everyone give a better round of applause, please.